being able to work in the nuclear medicine department at the University Hospital. And as part of that, I kind of, for the first time, got my interaction in medicine and saw what radiologists were doing. And I was like, wow, this is the greatest job in the world, right? Like I can't even imagine doing anything else. And so I kind of switched careers, or switched pathways or trajectories. Over the next year, as I was kind of preparing for med school, I started thinking about this idea, and this is in the early 90s, was how do you, with radiologists, you've got this very, very siloed expertise. How would you try to put it together in which you could kind of consolidate all this expertise in a single location? Now, back in the 1990s, we had things like ISDN lines. I mean, T1 lines were just exorbitantly expensive back then, at 1.5 megabits, right? And so I was like, well, maybe you could put a whole bunch of radiologists in the center of the country, in Nebraska or Iowa or something, and then send everything to that central location. And so I started kind of formulating this idea, and strangely enough, I actually wrote about this topic as my medical school personal statement. And, it didn't get me a lot of looks at medical schools for sure. It was about the most dry, non-appropriate, inappropriate kind of personal statement that you could imagine. But it started something inside of me. That went a little bit dormant in as much as, I kind of eventually got into radiology, matriculated, and during my second or third year in radiology, my chief resident, who's my co-founder actually, came to me and said, look, I want to live in Hawaii, you want to live in Michigan, how do we work together? And so we've basically said, yeah, I've been working on this idea, this teleradiology concept. It looks like it's starting to work now. Let's put it together. And that's really what we ended up doing. That was the genesis, because I kind of had this idea, and just by serendipity, one of the people that inspired me, and inspires me to this day because of how good he is, wanted to work with me. And so we said, let's put together a company of like-minded people that we love to work with, and try to stop thinking about things in the context of time and space, right? It shouldn't be geographically constrained. So teleradiology is a perfect application for this. And so when we started to try to form the company, we both arrived at, so we said, well, what is the foundational ethos, or what is the foundational principle for the company? And from my standpoint, I came to a conclusion and Ray came to the conclusion, but the great news was we came to the exact same conclusion, in that we distilled down to a single question, and we said, is this how you would want your family member treated, right? And although that may seem a little trite and simple, it actually is very appropriate, and it actually guides things. So if you answer in the affirmative, yes, you're doing the right thing. If you answer in the negative, you're doing the wrong thing. But I think the trick for us was that if you have to pause and think about it, you're typically trying to justify something, at which point really you're doing the wrong thing. So you have to carry yourself with the sort of moral and ethical ascendancy that you're always doing the right thing for the patient. And from there, everything else follows, whether it's a technical decision, a professional decision, anything, it doesn't really matter. And one of the things that was really critical that both Ray and myself viewed is communication errors. Simple errors in communication lead to significant outcome problems for patients. And so one of the things we were very keyed in on from the onset is that we're going to talk to the doctor on every case, negative or positive. And so we structured our practice around this idea of very high touch, high communication in an age in which radiologists were getting more and more clinically abstracted because of PACS, with technology surrounding us, allowing us to do things in ways where we didn't just pick up the phone and call somebody, you texted, you paged, you this, you that, but it got radiologists super clinically abstracted, and they just stopped talking to other clinicians. And this is a problem. This is something we viewed as a serious problem. And so we started literally our vision for radiology is how we wanted to practice. And that's what kind of led to the genesis of this. So that's, in a nutshell, that's it. It's a long story, but I appreciate you asking, and it's been a fun road. And out of curiosity, how did you guys get your start, Florent?
Well, it's the ethos behind the creation of the company was actually a little bit more prosaic. But of course, at the end of the day, our mission as a technology company is the same as yours, right? It's to serve the needs of the patient population and making sure that the diagnostics are done in a reasonable amount of time for good patient care. But the creation of the company was actually 12 years ago this week. February 8th of 2008 was when we started this company.
Happy anniversary.
And, thank you. And so 12 years ago, we started on this journey, but the journey started several years before that. And it probably started, if you think about everything that's happened since 9/11 in 2001, I would say that's when the genesis of our company really finds its root. So before starting Dicom Systems, the founder of the company, Dmitry Tochelnik, was actually CTO for another company in San Francisco, and I was CFO in the same company, and we were colleagues. And our entire mission as a company was to serve the military mission in Afghanistan, in Iraq, in Kuwait, in Germany, in the continental US. And that was by deploying teleradiology equipment in some of the most unforgiving parts of the planet. And that means literally in the war theater. And so we, after a few years of serving that war machine, right, the patients and in that case, the soldiers, the wounded soldiers, you have a massive amount of imaging data being created downrange. Downrange is another term for war theater. And so you have these clinics with CTs and MRIs and ultrasounds and massive trauma and casualties resulting from the war operations. These patients are flown to Germany to be stabilized before they are flown back to the continental US for stabilization and for treatment in the long run, and eventually transition into the VA system. And so throughout those workflows, you can imagine there is a technical infrastructure in the background, plumbing, if you will, that takes these massive amounts of data and move them from the Middle East to Germany, where there's Air Force radiologists that are reading the images. And before the patients would even get to launch stool, they would actually know what to do with them because they'd actually done a diagnostic with those images. It's just what you don't really think about is that there's satellite communication involved in this, and that we're talking 54 kilobit per second uplink to move 1,000 slice CT. You can think about all the challenges associated with that. So massive amounts of imaging data, low bandwidth, high latency networks, and the stakes are super high, right? Because you're trying to stabilize a soldier who was just wounded during the war. And so obviously teleradiology equipment is super important, but also supporting the mission of the PACS administrators, the IT directors, the network admins, all the sort of the unsung heroes of those workflows is what we chose to focus on as a company. And that's how Dicom Systems was created. And in fact, one of our colleagues literally chose to change careers after seeing one too many RPGs fly by the helicopter that he was on to go deploy some of that telerad equipment, right? So, when we do imaging in a really stable hospital clinical environment, yes, there's emergency rooms and there's a lot of stress, and of course patients are just as important in a conventional hospital as they are in a tent in the middle of the desert. But the technical infrastructure that's serving that mission in the background is super important. And that's what we chose to focus on, is that plumbing in the background. So we as a company didn't choose to become a PACS because there's a lot of PACS companies out there with viewers and workload balancing and a lot of things. But we chose to be the plumbers, and that's what we've been doing for the past years, and that's how we cross paths with Vision Radiology. So we're very grateful that that mission of ours actually intersects with yours today. But as a company today, we power in excess of 9 billion images being delivered to their rightful place. We do in excess of 15 million annual telerad reads going through our systems, and that's not counting the 45 to 50 million relevant priors that we also deliver. And so, interestingly, our own customers talk about this platform as sort of their Swiss Army knife, and the Swiss Army knife allows you to do a lot of different things. There's not a single thing that you should be focusing on using this tool set. We, as you know, in your own practice and your own technical people at Vision Radiology, there's a lot of different ways to deploy this technology and solve different types of problems. And so that's hopefully, a good answer to your question of how we
Yeah.
got this company started where we are today.
No, it's a great, it's a really neat answer, and both literally and figuratively, you guys are battle tested, right? Like that's pretty impressive. The type of conditions that you guys have to perform under, because we've got it easy, right? We've got hospitals with 100 meg wide area network connection. So I mean, to be able to perform accurately with that level of constraint is kind of a quite a feat, a technical accomplishment to say the least.
Yeah, I mean, we didn't survive it very long, right? I mean, we did it for a few years, and then, time to have a more peaceful life. So one thing that became really clear to us during that experience, though, is that this distinction between radiology and teleradiology, when you think about the technical advance that we've had for the past 4 years, that distinction almost disappears, right? There's such a fine line between being in a radiology group versus a teleradiology group. Essentially, you're still just doing radiology, you're just doing it in a distributed fashion. And so we tend to not even make that distinction anymore. Intramural versus extramural workflows to us are one and the same.
No, I love that, and I've maintained that same idea. Radiology is now teleradiology, right? Like, I don't think, I mean, those can be substituted. They really shouldn't be, with the exception of procedure-based things that you may have to be there for. Really, truly, I mean, that's how you should think of it, as this kind of distributed in time and space, as needed.
So now there's been a lot of interesting trends in the industry for the past few years. The one that intrigues me the most, and I'm really curious to hear your perspective on it as a radiology group or teleradiology group, is that trend of consolidation, right? We've seen a lot of radiology groups become part of larger groups. And this consolidation, I'm really curious whether you see it as purely driven by financial motives, Wall Street considerations, or if there are some real clinical and technological value elements to this consolidation. And so what are your perspectives on this?
Sure. No, it's a great question. So I think it's a little bit of both, right? I mean, there are some financial reasons why consolidation can be very valuable, right? The complexity of medicine is expanding, is ever expanding, right? The difficulty in the regulatory and legal environments is also ever expanding. And so sometimes an economy of scale can be very, very valuable. It can gain certain efficiencies to allow you to practice that you otherwise couldn't accomplish as let's say a small group, right? So yes, there are certainly some financial reasons. There's also this interesting cat and mouse game of insurance, because as groups get larger and larger, they can command reimbursement pressure from insurance companies because there's no one else they can go to. And in a strange sense, you can get sort of a physician union, as it were, established through corporatization. So definitely there are some financial advantages to the consolidation in these spaces. But going to kind of a more important thing is that there can be very, very great improvements in the ability to deliver highly specialized care, because as it is, things are getting more and more complex, right? So having specialists or being able to access specialists, 24/7 is incredibly valuable. And if you stop thinking of radiology confined in time and space, right, like the traditional bricks and mortar kind of, oh, I go into the hospital, I do this. If you start thinking about it in more adapted ways, right, like, hey, we've got one of our folks in our group that wants to live and work in Hawaii, but let's set them up there, and I'm on the East Coast. They can do things that are very, very valuable for the group, and you can use time shifting to allow them to bring expertise to bear. And to help ultimately improve patient care, patient outcome, and things like that. So from that standpoint, I think there's a very distinct advantage to being able to have larger groups cross-covering and sharing expertise across, let's say, a larger platform.
But that brings up a question of separation of duties, though, right? Because just because you
Yes.
have and physicians who are specialized in certain areas, how do you ensure that the right study is presented to the right physician at the right time? Because you have some, pretty impressive turnaround times in your practice. You need to maintain those turnaround times and SLAs. So there are two different ways that we've seen our customers for the past 12 years. There's two very radically different philosophies of how they handle the incoming queue, right? One of them is we just keep reading until the queue is empty, right? So let's say I have 150 cases on my work list. I'm a radiologist, and whatever case is next is the one I'm going to read next. And then you have the other philosophy, which is much more mechanized and much more systematic in its presentation of the studies to different physicians based on their preferences and subspecialization. And so those two radically different approaches ultimately result in the same thing. All those cases get read by a radiologist in time, to respect the turnaround time and the SLA. But what is your philosophy in Vision Radiology, and how do you handle those cases?
Okay, so let me take a step back from that real quick and say, I think both can be equally valid and valuable, right? It depends on so many local factors, right? It depends on, let's say, the caliber and quality of the clinicians and the type of reports that they're expecting. Because, you may have a highly specialized, let's say, orthopedic or neurosurgical practice that really demands a certain level of exacting precision on their cases, right? And so in those situations, you're going to need to staff it with, let's say, neuroradiologists or people who are very expert in that area, right? And other types of practices will have a somewhat more generalist approach to things. And it really depends. So I don't think that there's a right or wrong answer. And, I'd maybe throw in a third one, that there may be a hybrid somewhere in there as well, between the two, where some cases are read at subspecialty level, some are not. But I think this is where companies that can do workflow optimization can be very, very valuable for us, because based on each group and their needs, you can customize it. So it doesn't matter, what the preference is, as long as the company that's helping you with that is able to do that based on your criteria, it'll optimize your workflow, right? To get the images and the cases to the right person in a timely fashion, so that they can do that work efficiently. Now, so that's my general overall take. And then you asked a more specific question about, well, what do we do? Our group and company, we view ourselves, even though all of us have subspecialty practice and expertise and training, right? I did a musculoskeletal MR fellowship, and so my training, my subspecialty training is highly specific. But I love imaging. Like, I love almost all parts of imaging. I really enjoy chest, abdomen, head, neck, neuro. I love body. I love MSK. So we view ourselves really as emergency radiologists who tend to cross multiple disciplines, multiple subspecialties. And so as an emergency radiologist, right, like my interest is the whole body. I love it. And so I try to get good at everything. And and although it's a challenging task, the way we work is a first in, first out basis. We have very significant time pressures, just like everybody else, but in the emergency space, those are kind of amplified. And so we don't necessarily, the cases that we're getting, we kind of just segment them out as first in, first out. But in order to augment that, right, because I'm going to get stuck sometimes with really crazy cases, and I need to be able to, across my platform, be able to bounce things off of my colleagues. And the way we structured our practice, it is hands down the most collaborative practice you'll ever see. The whole night long, we're teaching, training each other, showing good cases. And so, I mean, and this is not lip service. I mean, we really do this. And so we really, you kind of have a little bit of that hybrid, because if I pick up a complex case, a neuro case, and there's an abnormal finding, and I'm not 100% sure, I'll just ping one of my neuro guys and be like, hey, this is what I think it is. Can you help me with this? Just make sure that I'm not missing something. And they'll give me guidance on that. And the value in that, even though it slows me down a little bit, the value in that is that I'm learning, right? And I'm continuously learning. So it's really, it'll allow us to get better professionally, because in 10 seconds I can get 9 or 10 consults from subspecialty trained people on a particular specific question that I have. So that's how we do it.
So in light of your mission and how you operate, a couple of years ago, you contacted Dicom Systems to solve a very specific problem, right?
Yeah.
we had an issue with a specific site where there was literally technologically no way for you to maintain your turnaround times if you were to stick with the technology as it was.
Mm-hmm.
So first of all, we're super grateful that you took the time to research and find us. You're technically savvy enough to understand the difference between various solutions, and you posed. We actually started out almost not working together, right? Because we had such an immediate emergent need to fix that issue. We don't like to make promises we can't keep,
Yeah.
right? As a company, and so I believe we almost had we almost went in different directions in the incipient stages of the relationship, and I'm glad we didn't, of course. But let's talk about the problem that you were trying to solve. The short end of the story is that we were able to do a 10x improvement in data throughput for that particular use case, but that became a more general approach for all of the sites that we help you serve. And so let's talk about that a little bit. There are two aspects that I think are very interesting. One of them is just compression of images, and the other is the multi-threading of imaging, coming into your packs. So would you like to talk about that a little bit?
Sure, absolutely. So, I think unfortunately for Dicom was not developed in the age of the wide area network, right? Like it was really developed in the age of the local area network. But as we talked about a little bit earlier, right, we need to stop thinking about teleradiology as being different from radiology. These are one and the same now. And we're going to continue to press that, further and further as far as it's going to go. And so I think historically, compression wasn't really needed. On a local area network, you don't really need that. But as you start to get to these distributed models, right, there's issues with respect to things like latency, right? Like if I'm transmitting an image 1 mile, it's not difficult because of networks and performance and stuff. But if I'm transmitting it 2 or 3,000 or 4 or 5,000 miles, right, there's an inherent network latency because as it goes from one server to the next, to the next, to the next, switches across the core, things get slowed down. So the wide area network is a very different environment than the local area network. And in order to succeed in that environment, you have to have an efficient way of doing the work prior to it hitting the wide area network, because it's got to be perfect on the way out. And this is where companies like Dicom Systems really come into play, right? Because you very quickly can implement, let's say, a VM at the local site, right? And you can do all of the hard work, the compression, the heavy lifting, and knock that study down. Your lossless compression algorithms typically go between 2 and 2.5, roughly speaking, right? So you can take let's say a gigabyte study and knock it down to maybe 350, 400 megabytes pretty quickly. And that's a huge, huge difference, right? So compression is critical. And if you can get that done before it leaves the local network and starts heading out to the wide area network, that'll improve your speed just by itself about 2 to 2.5 times. Just, so think of it from a doubling, you just get a doubling right there, okay? And then the next important thing is sort of parallel work, right? So, and this is a really good picture because it really illustrates what's happening. So, and it touches a little bit on a previous topic we talked about, which is that consolidation, right? We're getting bigger and bigger hospital systems. Some of the hospital systems we cover like 10 or 12 hospitals within that single system. And those hospitals can range from level 1 trauma centers to smaller hospitals, et cetera, but they can all be sending simultaneously through, let's say, the same tunnel or same pipeline. And so, when we do that, and sometimes they have a common PACS, when we do that, the PACS doesn't do this efficiently. It's actually pretty bad at it in many, many circumstances, right? And so the way, if that PACS, common PACS, or that local system is kind of sending it out, almost like those trucks at, I presume that's either Yosemite or I'm not sure, but all those cars, if they're sending it out in serial, right, it's very slow. And when you're talking about traumas, like a multi-part trauma case, and then a stroke case comes in behind it, that's no good, because that means your stroke reporting times are going to be much longer than otherwise, because you're just waiting to get the images, right? And it becomes an untenable situation. So that's one of the things we love about these store and forward servers that you guys have made. They're extremely efficient because they kind of parallelize everything. I'm not sure if that's a word. They make everything parallel, right? And so they really allow us to, if there's 6 or 7 or 8, 10 cases coming in simultaneously from a single hospital system, none of those get delayed. They're all going out in parallel. And so that has become a very, very valuable thing for us because, sometimes we can get upwards of 1,000 images per minute from a particular hospital system sending simultaneously through multiple hospitals, right? Which is a lot. And in particular, like this is a really good kind of example of the site that we first worked on. When we set everything up, everything looked good on surface, and then we started doing our image testing and stuff like that. And for whatever reason, and we could never identify the reason, we optimized, we did everything we could, the local PACS performance was not good. The modality performance was not good. Going out to the wide area, it just wasn't sufficient to do this kind of work. And I remember going to saying, look, I mean, we can get one image every 3 seconds. What if we have a neuroangio case or, a ruptured aorta with a, dissection protocol case? Those can have 1,000 images, 2,000, 3,000 images. There's no way we can get our results back in an appropriate time frame for optimal patient care, right? I mean, we'd be reporting an hour later because we're waiting on the images for 58 minutes. So this was really critical, and I think we didn't change anything except you guys put in the unifier, put in the VM, and then we had the PACS or modality send directly to the VM device, the unifier, and we didn't change anything else. And this is the difference we got. I mean, it was like a 10x improvement in performance at that site. And nothing else changed. And so we were obviously pretty happy with that. And that allowed us to do things in a much, much more consistent way with the site. That we knew we were going to get the performance out of the algorithms that are in place up front, so that we don't have to have kind of delays in reporting on the back end because we can't get the images quickly enough. So that was a long answer. Sorry.
No, not at all. This is a very important aspect of what we do, right? We're providing a technology answer so that you as a physician can spend more time being a physician, right? So that brings us to another important topic, which is, the less time you spend on trying to solve technical issues for your practice, the more you can spend time with your referring physicians and even with patients. I mean, I've heard some really interesting stories. I would love to hear some anecdotes from you about how, being freed up from these types of technical issues, you're now able to be an even better physician because of actual human communication improvement.
Yeah, no, and so let me tell you something just from last night alone, right? So because when you're fighting the technology, or when the technology really isn't augmenting you as the radiologist, and you're kind of working through the technology instead of with or in parallel to the technology, it just makes it that much harder, right? And so, we have some fairly rapid turnaround times. We have, and we also call in all these cases. Like, I'm talking to the doctor, even on a negative exam, I'm reviewing with the doctor. And there's a case from last night that I saw, and, the patient had come in multiple times to the ER. She had left lower quadrant pain, right? And nobody had really kind of done a proper history, physical, nothing, right? And so, I called. Unfortunately, the doctor was tied up with a fairly emergent situation. So I was talking to the nurse, and I was like, well, I see something subtle in the left rectus. This is a non-contrast abdomen pelvis, something subtle in the left rectus muscle. And then there's this subtle kind of, 8 millimeter thing between the uterus and the bladder. Okay, little mass-like kind of thing. And so I was like, hey, do we know anything about the patient's menstrual history? Do we know anything about the patient, blah, blah, blah. And she's like, no, but I'm like, well, do you have a portable phone? She's like, yeah. So let's take the portable phone in and do a proper history with the patient, right? And so the nurse took the phone in, put me on speaker, and I talked to the patient, and I said, and mind you, radiologists don't usually do this, right? Like, this is not, but because of the speed and efficiency of the platform, the system, I'm able to do this. I'm able to take the time to do this, right? So I was like, ma'am, how long has this problem been going on? She's like, oh, it's been going on for like a couple of years. I'm like, okay. And does this happen like right before your period? She's like, yeah, every time it happens right before my period. Like, and after your period's kind of done, does it kind of go away? She's like, yeah, it completely resolves. And do you have any of these symptoms between periods? She's like, no. Like, okay, great. And how many cesarean sections have you had? So I've had 3. Okay, so now, and for any of the radiologists in the room, they kind of already know the diagnosis. This is an endometrioma. So when you have a cesarean section, you kind of, you're cutting into the uterus, and some of those uterine cells actually can get implanted inside of the abdominal wall. They're very hard to see and pick up, very, very hard. But it's because I got to talk to the patient, right? I did a virtual history and physical, well, not physical, but I did virtual history and that patient was over 2,000 miles away. But I got to take the time to do that because my system is working efficiently, right? And so I was able to make a specific diagnosis. She, now we know exactly what's going on. And for more than a year, nobody had figured this out. And I'm not saying like, oh, look at me, I'm so great. I'm just saying like, it allowed me to take the time to do the right thing for the patient. And again, it goes back to my original mantra, is this what you'd want for your family member, right? That high level of touch, high level of communication, whether it's with the doctor, the patient, the otherwise, it doesn't really matter, but it's communication that is critical in medicine, not technology. And I'm saying that as a as a person in technology, it's really that simple. That communication is the crux of what we do in radiology. Now, the technology is critical in as much as it helps us achieve our end goal, or it can hinder us getting to our end goal. But it's really that communication, and medicine is still very, very human. It's not technology in and of itself.
Absolutely. And part of this communication between you and the referring physicians has everything to do with context, right? The more context you have available to you as a physician, the more accurate you're going to be.
Absolutely.
Right? If there's
yes.
a whole history of anything that you're unaware of, then you're also unaware of the reports that came with those studies, and you're unaware of history that could be guiding you in a different direction. And so that brings us to a part of technology that we make available to our radiology customers, and that's the ability to really filter and hone in on the relevancy of priors, right? So a patient might have, 30 years of history of X-rays and MRIs and ultrasounds and CTs, and only a fraction of those may be relevant to the current case. And so one of the ways that we let you be a better, more efficient physician, as well as the technologists and the PAs, is by not having to track down information manually, right? So we make sure whenever we have that initial through that we prefetch and filter out unwanted traffic. Because if you go back to the concept of network efficiency, if you have 10 studies coming through, only 3 of which are relevant, now you're taking up bandwidth and computing resources for something that's not going to be useful to you in your mission as a physician. And so the concept of relevance, and not all PACS companies are created equal, right? And so they may give you some very simplistic rules to bring in priors. You may have 2 or 3 different criteria, like patient name, date of birth, etc. And all of a sudden you end up with a plethora of irrelevant priors that are cluttering your PACS. And so what we've done with some of our Telerad group customers is create collaboratively with the physicians synonym lists that we built into the rules as Lewis scripting. And those synonyms are something that the physicians themselves can collaborate on and make sure that when we bring in a relevant prior, it is in fact relevant, because it's based on physician preference and it's based on high relevancy criteria. So I assure you, this slide here is not an advertisement for Tesla. We like our Teslas, but it is true that if you don't pay attention to the algorithm that's bringing in those priors, you're going to end up with completely irrelevant priors in your work list.
Yeah, and let me kind of second that, right? Because from our standpoint, our workflow can be difficult because I don't know what is existing at the local site, right? Because as a remote practicing radiologist, I don't have like an open kimono into their PACS and into the patient's archive. And so from my standpoint, having all that prefetching is very, very valuable, because the worst thing is when I pick up the phone and call a doctor and he's like, oh, well, how did this compare to the prior? And I don't have the prior because I didn't know it existed or it didn't get pushed to me. You look kind of silly and that's one part of it. You look kind of silly, but then there's the other part where now you've got to go back, track down the tech, say, hey, you know, can you go ahead and send this prior? I guess is, you know, I'm not sure what. That's not efficient for me to be managing that workflow, right? Because it takes me away from image dwell time, from doing what I'm trained to do, not track down films, as it were, or track down studies. So yeah, this is actually quite valuable and helpful.
So we've covered quite a bit of grounds. So we have 5 minutes until our Q&A session will begin. I know we've had a few questions already. Our marketing team is making sure those are queued up. So let's have a few closing thoughts on what we're doing in teleradiology today. We've talked about the fact that we don't really distinguish between radiology and teleradiology anymore. We haven't talked at all about this tsunami of artificial intelligence that's coming at us in this industry. You know, all of us on this call that go to RSNA or the HIMSS conference get bombarded by AI routinely, and we're going to do a separate webinar on this topic alone, because if you think about the number of companies that have sprouted up in the past few years that are venture-backed, that are creating technology, it's inevitable that they're going to impact us as a technology company and you, Dr. Agrawal, as a teleradiology practice. And so I don't want to have that conversation in this call because it's too big of a topic, but we should agree to have a follow-on conversation to specifically talk about that, the technical ramifications and the human ramifications of AI in our field. Any parting words you'd like to have before we go to our Q&A session?
Sure. I mean, I think for me, as a person in technology and also in medicine, I think the striking thing for me is that physicians need to be at the front of this discussion, right? Because it's very important that, because let's say an IT person who doesn't necessarily have a clinical background, a real clinical background, oftentimes doesn't understand or know the implications of what they may be proposing, right? Or how that solution may affect the downstream clinical, right? And so having physicians really participate in some of this stuff on a very meaningful and deep level, I think is critical, because otherwise you design solutions that sometimes may not work for the end user, and by proxy ultimately don't work for the patient and the clinician in this case, because the radiologist is now not as efficient or effective as they could be. So those would be my kind of sort of final thoughts on this.
Very good. Well, we have a few questions that I think are going to take us a little bit of time to answer. So I'd like to switch gears here and go to answering them. The first question from Aaron is, does Vision use more than just Dycom transfer functionality of the Dycom systems offerings? Do you automate your preliminary results back into the primary rad group's RIS or VR system?
So, so the short answer is yes. yes on all of that. So we use, I think, several different aspects of Dycom systems in terms of like what they can do. I don't think we've even scratched the surface, honestly, because the way our practice is, I think we're only using a small fraction for the type of workflow that we do. But we obviously use it for the type of routing. We're working on projects for intelligent pulling of these of, let's say, the priors and reports and things like that. Florent, can you remind me? So we do use some tag mapping for a number of sites so that we can create a much more simple results interface instead of doing bidirectional orders interfaces and orders updates and things like that. So we've got actually a more efficient system that is much less susceptible to breakdown overnight, And so from that standpoint, we use tag mapping, tag morphing, and things like that on the Dicom systems unifier. And then let's see, what else? I don't know, Florent, currently if we send you guys reports directly. I don't think we have an example of that, but we could easily send a report to you and have you guys do the mapping out to their, let's say to their EHR, EMR, RIS, whatever it happens to be, or power scribe nuance kind of thing. But we haven't done that specifically, but I know we could if we needed to.
Yeah, I mean, across the population of hospitals that we help you serve,
Mhm.
there's not a single that looks like the next workflow, right?
Right.
They're all. So the next question is for you, Dr. Agrawal, of course. A 15-minute turnaround average seems very difficult to deliver, especially with sending data over distributed networks. Does image transmission time contribute to the radiologist turnaround time? In other words, when does the clock start in your organization?
So yeah, that's an excellent question. The clock starts when we get the first image. And so we don't, for us, I can never call a turnaround time when I don't have a study, for example, but we track it from the time the first image is received to the time we finalize the result.
Gotcha.
And interestingly, with our company, it's a little different, in as much as because we call all the cases. Strangely enough, like I pick up the case, I call, and then I kind of do my dictation afterwards, because it's actually a lot more efficient to do it that way for us. So my discussion time, or my final time, is actually not when I finalize the report. It's actually when I talk to the doctor and exchange the medical information. So it's a little different than a traditional practice, where you're not doing as much high touch, like very white glove level of service. If you're kind of just sending it out, obviously you'd use the time of finalization as your endpoint.
Mm-hmm. Excellent. And then we have a question coming from one of our partners in Montreal, I believe, from Emmanuel. So it's about the performance improvement. 3 images per second is between the PACS at the facility and Vision Radiology. Is that correct?
No. So that's 3 images per second. So the PACS typically, in these scenarios where you have the unifier in place, right, the PACS will send to the unifier, not to us directly. So really, it's 3 images per second from the unifier to us.
Okay.
And that's on a single thread, right? We can get much higher rates if there's more than one study part. So for example, let's say you had a CT, let's say you had a trauma case and you had a head, cervical spine, chest, abdomen, pelvis, T-spine, L-spine. If those are not all crammed into a single object, right? If it's all in separate studies, and you send, let's say, 6 or however many that was, 6 or 7 of those from PACS, all of those come into the Dicom systems server, assuming that the PACS can do it, but that's on a LAN, it comes in very, very rapidly. And I'm not, we don't have the visibility on that side. But the moment those images start to hit Dicom systems, they all start streaming to us. So, we can get 10, 12, 15, 18, 20 images per second, because it's all paralyzed. Paralyzed is not the right word. Parallelized is probably not the right word, but it's all parallel. I keep wanting to say the wrong.
Parallel processing.
Yeah, parallel. It's all parallel.
So the second part of the question from Emmanuel is, how does the physical distance between a facility and Vision Radiology impact time of transaction?
Yeah, that's an excellent question. So the physical distance is actually a pretty big impact. So now when you think about it, so per 1,000 miles of physical distance, you have about 40 milliseconds of latency on the network level. So if you're about 1,000 miles away from a site, you have between 40 and 50 milliseconds. If you're 2,000 miles away, you have between 80 and 90 milliseconds, 90, 95. If you're 2,500 miles away, you're up in the 110, 120 millisecond range. And from a practical standpoint, you basically get, per 1,000 miles, you get roughly half the throughput. So we have sites that can do 5 images a second, 7, 8, 10 images a second. I believe Stanford uses you guys, right? And so the Stanford server does something like 8 or 9 images per second, because they're kind of fairly close to the data center, within 100 miles. So it can be upwards of 8 or 9 images per second on a single thread. And again, if there's multiple studies, that can get up to 20, 30, 40 images per second.
So in other words, the answer is a variable, right? Because we first of all, we can't outrun the laws of physics.
Right.
Distance will definitely impact your ability to deliver or send images, depending on the distance between the facility and the place where they're going to be read. And so we, as a company, our philosophy is, again, we don't make promises that we can't keep. And so, before, we obviously have some baseline of performance that we can refer to. We have a lot of benchmarking information available for you to pour over. But when we engage with a new customer, we do a lot of forensic work before we even begin to deploy anything. Now, if we in fact have an emergent need to deploy something because you have a new client and you need to solve an issue quickly, now we'll do that. But if it's a complex installation, it's very important that we know everything about the environment in which we are expected to operate. Let's switch to a different question. Aaron wants to know, can you share what PACS you use, any challenges integrating it with Dicom systems?
Sure. So the company that we've used from our inception actually is a company called Avreo, A-V-R-E-O. I think we have a very customized product with them. I have been working with them for 17 years now, and we do a lot of their pre-alpha work even. So they'll send out, hey, here's a new version of this. Try to break it, find all the bugs, and so we're very, very intimately tied with Avreo with our PACS. We don't have any current existing direct integrations because for the type of work we do, we don't necessarily need to integrate it with the Dicom systems gateway, the unifier. But we could if we needed it. I wouldn't foresee a problem with that type of integration, but it just isn't needed. And I think that kind of speaks to one really valuable thing that you guys do. You've elected to be fairly vendor neutral, right? It doesn't matter who you work with. You pretty much work with anybody. And I think that's actually very valuable because if it was that specific, the product would be a lot less useful,
Absolutely. Interoperability is a core part of our value proposition.
Yeah.
And we pride ourselves on being as vendor neutral as we can be. And after 12 years in business, you can imagine we've touched every PACS that matters out there, including a handful that, have been absorbed by other PACS companies. So we have a few more questions. First of all, we have Rick Primo in our audience. We're really thrilled to have you, Rick. Thank you for joining us. Your question is, am I correct that the PACS itself is a limiting factor with which images can be transmitted by the unifier and then limiting the speed? I think that's not entirely correct. I think you're partially correct because not all PACS companies are created equal. So a PAC's ability to send to Dicom systems may be faster or slower depending on what kind of workload it currently has, right? So depending on what our mission is with that particular operation, for example, if we're doing a massive de-identification project for machine learning purposes, the PACS, no matter what it is not going to be able to send us 5 million exams without impacting its own imaging operations, right? So if we're doing a large de-identification project, we're going to direct level access to the images versus trying to query retrieve all of the images. That would be an extremely limiting factor in our ability to transmit the images, right? But in general, receiving images from a PACS is not necessarily a challenge unless that PACS is unable to somehow do parallel processing with us. So we'll need to serially receive from the PACS, and then from there, we can parallel process that and take those exams and turn them into multiple threads to do the transmission much faster. I hope that answers your question, Rick. And then Aaron has another question. Does Dicom Systems provide your reading Workless management tools, or is that part of your PACS or a separate piece of software?
So yeah, we use our Avreo RIS PACS for our reading Workless management.
So that's actually a really interesting question, right? Because it goes back to part of the discussion earlier, is that radiology group's philosophy in reading, right? So the workload balancing itself, once the exams are available on a work list, how do you process those? And so as Dicom Systems, we can of course provide quite a bit of workload balancing in the background based on, all kinds of Dicom tags, based on any kind of, sophisticated or simple rules. We can route the images to various places. But by far, most of our large telerad groups that use our technology use the philosophy of just read whatever is next on the work list. It just doesn't matter what's next. We're just going to read it. It needs to be read anyway, right? We don't do actual reading work list with Vision Radiology. That's not our role, right? Our role is to be the plumber, not the PACS. And so we just bring the water to the faucet, and then Avrio is the faucet. So I believe that's the last question that we had. I think I may have seen another question come through. Nope, I think we are. Is there one more question? Wait one moment. Okay, so the question is, HD tomo images are huge. Bandwidth from outlying sites is costly to upgrade to maintain quick reading. High-end mammo diagnostic monitors costs are huge. Third-party add-ons for specialty functions that the existing PAC system does not do. Can you talk a little bit about those kinds of aspects on the impact of those costs could be on your practice? I think those costs are actually more likely than not absorbed by the facility that produces those images, right?
To some degree, yeah. So let me put a big asterisk star caveat on this. We don't do any mammography. We do emergency teleradiology. We do some daytime consult work, but it's not in the mammography, breast imaging space. That being said, the 3D tomos, the 3D breast images they're very large data objects, and they're actually akin in many ways to even like cine clips, right, for ultrasound in that sense, in the potential size of the data set. So one of the interesting things about this is that as the object gets very large, the Dicom chattiness actually goes down. And so when you compress the data, let's say you've got it lossless compressed, so you can recover it to its original format, once you've gotten it, it's actually quite a bit faster than you might think, as long as the system is optimized to do this. So, like a 400, so let's say you have a 3 gig data set, right? And so that's going to compress down to about 1.5 gigs, right? Well, if you've got 1.5 gigs to transmit, even if you have a large amount of latency in a single thread, that's going to take forever. It'll take 30, 40 minutes, 50 minutes, 80 minutes to get through. But here's the thing: 1.5 gigs of CT images will take that long. 1 gig of, let's say, a volume data set that has, let's say, a large object in it actually goes much, much faster because it doesn't require all the back and forth chattiness of Dicom. So it's actually surprisingly efficient. So I'll give you an example. We can send an ultrasound with a 10-minute cine clip in it. That actually can be faster than a 4,000. It's actually like 5-10 times faster than a 4,000 slice CT that has an equivalent data volume. Does that hopefully answer the question that large objects actually transfer much faster because they don't have the back and forth latency effect because of the chattiness of the Dicom protocol?
Well, and there's another aspect of this, that different systems will actually wait for all the objects to be transmitted to the stored forward device before they start to transmit. We don't do that. I mean, most of the time we'll actually begin to transmit before storage commit would happen. And so there's a lot of different ways to look at that, but one of the ways we solve that problem is by doing our job immediately, meaning transmitting immediately. Okay.
So, yeah, and you guys are very, I gotta say and emphasize, you're very efficient at this. And I'll tell a very tiny story, hopefully, if there's enough time. So we recently were mucking around on VPNs and stuff and trying to kind of block unnecessary traffic and this and that there. And then we just out of simple rule, we'd kind of at such and such time all the VPNs would open up. And we had a very bizarre situation where the Dicom system server was kind of had a bunch of stuff stored up, and our system got so flooded it looked almost like a denial of service attack. It was that efficient at moving data. We were like, what is happening, right? And then we figured it out, but it was like, I don't know, I've just never seen anything quite like this. It is very, very efficient at moving data from point A to point B.
So one of our Telerad customers who's on the line makes a really interesting point. I think it should be mentioned. Chris Rady at Foundation Radiology says, we do centralized mammo screening and we are able to deprioritize the TOMO or all mammo data sets using the unifier tool. So meaning that prioritization of the routes is also an important aspect of this. So if you have large data sets that may or may not be for an emergency read, you can deprioritize it. It still transmits, just at a slower pace. Thank you, Chris. That's a really important point to make, is that we can actually act on the routes based on the existence or even the absence of certain data in the data set. So one interesting thing that I think is worth talking about in the last minute that we have together here is what does it take to deploy an incrementally new site that you need to read for?
Yeah, so again, efficiency the whole way around. I think I've worked with a number of different folks across the spectrum, and I would say your technical and implementation team is hands down the fastest and most effective team I've seen so far. Irrespective of the vendor. Honestly, they are just very, very efficient. I mean, we've had implementations done in like less than a week. From start to finish, and end to end done. Like, that's how quick they are, with a lot of other features and things added in. So I don't want to put you on the spot, making that the de facto standard, Florent. But I mean, from our standpoint, it's not something that I even have to think about, because it's efficient, correct, accurate. I don't. It's kind of, I just let them know that this is what we need, and it gets done.
I appreciate the input. I mean, in all fairness, our ability to deploy is not strictly based on our own efficiency. It's highly contingent on, your team's availability and also the other vendors' availability as we do the integration, right?
Yeah.
We're in an ecosystem. We don't live by ourselves, right? So it takes a team to make this happen together.
Yeah, but I would emphasize that I don't think your team is ever going to be the rate limiting factor in this. Just from our experience, we've never seen that.
Yeah, we try to stay awake on the job with lots of cats.
For sure.
We've reached the end of our webinar today. I want to thank the audience for their participation, for their questions, their thoughtful questions to us. And of course, you, Dr. Agrawal, for your generosity with your time and your input. We really look forward to doing this with you again. We will announce the next webinar pretty soon, but it will be focused on the topic of application of AI in the teleradiology field. And of course, everyone's questions, topics that are important to our audience are very important to us to talk about, right? We don't want to just have an agenda that talks about what we want to talk about. What's important to our customers needs to be talked about in this context, in the webinar. So I would encourage you to interact with our marketing team. I would encourage you to come see us at the HIMSS conference and talk about those things, because in many cases, some of the problems we solve for our customers, large or small, could be very applicable to the problems that you may be experiencing in your practice. And so don't hesitate to ask. Chances are we've probably solved an issue that you're experiencing. You just don't know that you don't know it. And so let's talk about it, and let's schedule our webinar based on topics that our audience cares about. Thank you so much, everybody. The recording will be made available to all of you. Have a great day.
Thank you.